Today, we're talking about more different types of indefinite integrals. Okay, the first one that you have is the integral of 1 over x dx, okay, which is equal to the ln of x plus c. Okay, think about it, the derivative of ln of x was 1 over x, so it's only right that when you go backwards, the antiderivative of 1 over x is the ln of x. And the integral of e to the x dx is our good old e to the x plus c. Do not forget, when it's an indefinite integral, okay, with just the integral symbol, nothing else, you always got to remember to add your plus c. So looking down at these examples, it says find the indefinite integral. So the integral of 4 over x, that can be written as 4, integral symbol, 1 over x dx, okay? That's applying your constant multiple rule. That's what allows you to pull that 4 out. So then, this looks just like that. So then you'll have 4 ln of x plus c. Over here, can I do the same thing? Can I pull out a constant?
Yes.
What constant?
1/2.
1/2. So 1/2, the integral e to the t dt. Now this looks just like this. So you'll have 1/2 e to the t plus c. Okay? Now sometimes simplifying the integral can help you in the process of taking the antiderivative. Okay? So give you a second to write these down. Find the indefinite integral. The first one, we have the integral of x squared plus 1 squared dx. Okay? Now sometimes simplifying this can help. What do you think we can do to make this a little nicer? FOIL. So it becomes the integral of x to the 4th plus 2x squared plus 1 dx. Okay? So we can FOIL that, and then we just take the antiderivative of each piece, right? What's the antiderivative of x to the 4th? 1/5 x to the 5th plus, what's the next part? 2/3 x to the 3rd. The antiderivative of 1. And don't forget your plus c. Remember, you add 1 to your exponents, and you multiply by 1 over that. That's how we got 2/3. What do you think we can do with b? To simplify for b, what do you think we can do? Huh? Bring the x up?
Divide off the x.
Dividing out the x? Divide each one by x?
Yes.
That'll probably be a little easier to try to bring that x up. Okay? So now we'll have the integral. When I divide 3x squared by x, what is that? When I divide 2x by x, what is that? And then this will still remain 1 over x. And I did forget a dx in this problem. Okay? And now we can take the integral of each piece. I mean, the antiderivative. What's the antiderivative of 3x? 3 over 2x squared. What about a 2? 2x. And we just talked about this one. What's the antiderivative of 1 over x? ln of x plus c. Yes?
So we use the same process to find the c?
Yes, we still use the same process to find the c. But now just dealing with the different types of integrals you can experience. So all those other ones, they were simple ones, they were basic. Okay? Now we're getting to your more fancier ones.
What's the quintile dx?
It's the notation that goes along with it. Just like we don't say f equals, we say f of x equals. All right, and this last one, how can I simplify this? Ln of e cancels out, because what's the ln of e? 1. So this is the same thing as saying the integral of 2t minus 1 dt. And we can do that, right? Simple. The antiderivative of 2t, t squared, minus t plus c. Okay? So don't forget those good old school rules. Foiling, simplifying, L and B equals 1, so on and so forth. Okay? Questions? All right. Here's some other special ones. If you have a second to write these. Here are some indefinite interval rules that you guys probably are going to have to remember because they are not in your reference packet. Nope. They're not in your reference packet. That involve the linear function, okay? Everybody knows what a linear function is, right? So give me an example. 2x plus 1. Okay? So if it asks you to take the antiderivative of 2x plus 1 raised to a particular power, this is the process that you would have to go through. It's kind of like just taking the regular integration, but then you have to take into account that you actually have a function on the inside. It's kind of like its chain rule for integration, but it's not called chain rule.
It's like substituting the x for a something like that.
Yes, well, it's like, well, not substituting x, but like taking the coefficient that's with the x, taking it out, and then doing normal integration, and then adding a plus c. Okay, so does everybody see that? So if I wanted to take this example, say it was 2x plus 1 raised to the third. So a would be 2, so this would be 1/2 times 1 over n plus 1, which is 1/4. Bless you, times the original linear function raised to the 4th plus c. That's how this would be set up. That's how this would work out. You see how the pieces match up, where they go? So ax, that's where the 1/2 came from. So that was a. N plus 1 would be 1/4, because n was 3. You add 1 to it, that's how you get 1/4. This is the normal linear function that was on the inside, and then n plus 1. So my final answer would be 1/8 2x plus 1 to the 4th power plus c. That would be your final answer. Okay? Now, can you expand this and then take the integration of every part? Yes, you can. But remember, we're on time constraints here. Okay? That's a fallback, though, of course. It is e to the ax plus b. So if you have e raised to a linear expression, 2x plus 1, even a 4x. A 4x is a linear expression. Okay? This will be your process here. Whatever a is, 1 over a. And if it's 1 over a linear expression, then it's 1 over a ln of that linear expression. Okay? So whenever you have a linear function that you're taking the integration of, whatever a is going to have an impact. You see that? It's always 1 over a. And then it's the normal integration rule. Does everybody see that? So it's 1 over a and then the normal integration rule for that particular thing. If it's e, the normal. 1 over is ln. Okay? Yes?
So if you said even 4x is a linear function, you have to go through that process instead of that constant function or whatever we were using before.
Mm-hmm.
You have to do this.
Right, because the 4 is not in the front.
So is that only if it's with an e, or is that like I'm just talking about 4x by itself?
Oh, 4x by itself? No. 4x will go to the normal constant multiple rule. With e to the 4x, then that you're going to have to apply here. So like if this was my example, it would be 1 over 4 e to the plus c. Does everybody see that?
Wait, how would a equal 4?
Because this is your linear function at the top. You have your ax, your plus b is technically a plus 0, so it still applies. Down here, if I have 1 over 2/3 x plus 2, that would never happen. Okay, let me try that again. No, they write it as 3 over 2x, like they would do the fraction within the fraction. So say it was 1 over 3x plus 2 dx. It would be 1 over 3 ln of 3x plus 2, your linear function that's down at the bottom, plus c. Okay?
Maybe they were like, do like a radical on the bottom,
They could do a radical on the bottom.
or it'd be like, if we were to change it to like a fraction.
You definitely want to change it. Okay, so let's look at a few. Okay, let's look at a few together. So A, was it number 1, number 2, number 3? It's like number 1. You have your linear function raised to a power. So it's going to be 1 over A, which is 3, times 1 over n plus 1, which is 5. 3x plus 1, the linear function raised to the 5th power, plus c. And then you multiply your two fractions. 1 what? 15. Can I distribute that 1/15 into the parentheses? Why not? Because that linear function that's in the parentheses is being raised to the 5th power, not 3/15 x plus 1 being raised to the 5th power, no. Just that quantity. So you leave that 15 on the outside, don't you dare distribute it. B, is it like 1, 2, or 3? 2. Okay, so it's going to be 1 over A, what's A? 2. E to the 2x plus 5 plus C. That's it. Let's look at C. C is like which one? 1, 2, or 3? 3. Only difference is there's a 3 at the top, not a 1.
Yeah.
I can take the 3 out. Because then it becomes 1 over 4x minus 2 dx. Okay? Yes?
Why didn't I think about it?
Because the 3 applies to the numerator. Okay, and so if we were distributing back through, it only goes to the numerator. Only time you take something out of the bottom, it ends up being a fraction. So if I, like a 1/4, I can take that out. So now this is definitely like number 3. I just have a 3 on the outside. So I have my 3 on the outside. Then I have 1 over A, which is what? 4 times, oops, not times, ln of 4x minus 2 plus c. And then I multiplied that 3 to that 1/4 to get 3/4. And the last one. 1, 2, or 3? 3. So it's going to be 1 over A.
6.
Then
Plus
questions.
Would there ever be a number outside, like, for instance, A, there would be a number outside the 3x plus 1? On, like, A? Like, there would be a number outside there? Would they do that?
Yep. But then that would be that constant that you can pull out
Okay.
and put in front of the integral. Yeah. So So like number two, pull that two off.
For A and C, would you ever put the constant back into the thing and make a like 3/5 times 3x plus 1? For C, it would be 3/4 ln for us.
Yeah, this for C, yes. That, cause then that would be your final answer, that 3/4 ln part. But here, since there was no constant or anything like that, it was just 1 over A and then 1 over n plus 1, you would multiply those together to get 1/15 here. So you do wanna multiply those, but you don't wanna distribute into the quantity. Does that answer your question?
If there was a 2 in front of 1, would it go into the 1/3 or 1/5 or after you multiply the 2?
It would be after you multiply them together. Either way, you can do 2 times 1/3 and 2/3 and 2/3 times, same thing. Okay? Stop here, I'll say substitution